Hello, dear friends. Today, we take a journey back in time to the first recorded sighting of a celestial phenomenon that has captivated humanity for millennia, Halley's Comet. Our journey begins around 240 years before Christ, when the comet made its grand appearance in our skies. This is no ordinary comet. Halley's Comet is a short-period comet that graces our skies every 75 to 79 years, making it possible for it to appear twice in a human lifetime. Imagine that. A comet so persistent it might just wave hello to you twice. But what exactly is this comet? It's a celestial body that orbits the Sun with a highly elliptical path and brings with it two spectacular meteor showers, the Eta Aquariids in May and the Orionids in October. If you find the universe and its wonders as enthralling as we do subscribe and share this video. There's so much more to uncover about this fascinating comet. So, stick around as we explore the fascinating history and science behind Halley's Comet. Over centuries, this bright comet graced our skies every 75 to 79 years. Yet it was not until 1705 when a brilliant mind connected the dots. That brilliant mind was none other than Edmund Halley, a renowned English astronomer. His fascination with this celestial body led him to dig into historical accounts of comets, tracing their appearances back to 240 BC. He discovered that a remarkably bright comet was recorded in the annals of history roughly every 76 years. The comet was seen in 1066, a sight that is famously depicted in the Bayeux Tapestry. It was seen again in 1531, then in 1607, and yet again in 1682. Observing this pattern, Halley proposed a daring hypothesis. These were not separate comets, but rather the reappearances of the same one, making its grand tour around the Sun. Halley predicted that this comet would make its next appearance in 1758. He wouldn't live to see his prediction come true, but when the comet returned, just as he'd anticipated, it was a momentous occasion. Halley's prediction not only validated the laws of motion proposed by his friend Isaac Newton, but also marked a significant shift in our understanding of the cosmos. From that point forward, the universe was no longer a place of unpredictable phenomena. It was a universe governed by laws and cycles. In honor of his groundbreaking work, the comet was named after Edmund Halley. Today we know it as Halley's Comet, a fitting tribute to the man who taught us to anticipate its return. Halley's prediction marked the dawn of modern astronomy, shifting our understanding of the cosmos. His legacy continues to inspire us to look up at the stars and wonder, what else can we predict about this vast, beautiful universe we call home? As the comet follows a highly elliptical orbit, it brings it close to the Sun and then flings it back into the depths of our solar system. Fascinating, isn't it? This is the celestial dance of Halley's Comet, a cosmic ballet that has been going on for millennia. Now, let's delve deeper into the comet's unique structure. Comets, including Halley's, are often described as dirty snowballs or icy dust balls. They're basically a nucleus comprising a solid core of water ice, frozen gases, dust, and rocky material. When they approach the Sun, they heat up and spew dust and gases into a glowing head that can be larger than most planets. This forms a coma, an envelope around the nucleus, and as the comet continues its journey, the solar wind sweeps the coma into a long tail that points away from the Sun. Halley's Comet has a highly elliptical orbit. At its closest point to the Sun, known as its perihelion, it's just about 0.59 astronomical units away. That's closer than our planet Venus. But at its farthest point, or aphelion, it's 35 astronomical units away, which is roughly the distance between the Sun and Neptune. So, this comet is quite the traveler. What's more, Halley's Comet has a retrograde orbit. That means it moves in the opposite direction to the planets in our solar system. It's like a car going against the flow of traffic on a cosmic highway. And it's not just doing a quick lap around the Sun. No, Halley's Comet takes its time. With an orbital period of about 76 years, it's not in any rush to complete its journey. The last time it swung by was in 1986, and it's next expected to grace our skies in the year 2061. This cosmic dance indeed makes Halley's Comet a sight to behold. But did you know, this comet is not just a solitary spectacle, it brings along celestial fireworks too. Yes, Halley's Comet is associated with two meteor showers, the Eta Aquariids and the Orionids. These meteor showers are an annual occurrence and are actually the result of the Earth passing through the trail of debris left by the comet. As these tiny bits of comet dust enter our atmosphere, they burn up, creating the beautiful streaks of light we see in the night sky. The Eta Aquariids meteor shower peaks around the beginning of May each year. This shower is best viewed from the southern hemisphere, but can also be seen from the northern hemisphere. The meteors appear to originate from the constellation Aquarius, hence the name. On the other hand, the Orionids shower, which peaks around mid-October, is visible from both hemispheres. The meteors seem to radiate from the constellation Orion, giving this shower its name. But remember, you don't need to locate these constellations to see the meteors. Just find a dark spot away from city lights, lie back and look up. You'll see these meteors streaking across the sky anywhere from 30 to 70 times an hour at their peak. So even when the comet is not visible, it leaves us a stunning display to admire. In 1986, for the first time, we had a close encounter with this celestial wanderer. It was a historic moment in our quest to understand the universe. As Halley's comet made its scheduled visit to the inner solar system, we were ready with our spacecraft to observe it in detail. The information gathered was nothing short of revolutionary. We were able to observe up close the structure of a comet nucleus, a chunk of ice and rock, the heart of the comet. We saw how the sun's heat transformed this icy nucleus into a glowing coma, a cloud of gas and dust that surrounds the nucleus. And we watched as the comet's tail, a stream of gas and dust, was formed, always pointing away from the sun due to the solar wind. This encounter with Halley's comet was not just about gathering data. It was about understanding the birth of our solar system, about tracing our cosmic roots. Comets are some of the most primitive bodies in the solar system, remnants from its formation over 4.5 billion years ago. By studying comets, we can learn about the conditions that prevailed when our solar system was just a baby. Our rendezvous with Halley's comet also underscored the importance of scientific exploration and cooperation. It was a global effort, with spacecraft from different countries working together to observe this celestial visitor. It was a testament to our curiosity, our perseverance, and our ability to work together in the pursuit of knowledge. As we anticipate its next visit in 2061, we continue our quest for knowledge, guided by the light of Halley's comet.